Hello everyone, and today we come back to the second part of this lecture. So I'm sorry for a bit delay that we have couple of meeting because the situation of COVID-19 that changed. The government changed the policy day by day about we gonna run and organize the university, and basically right now we encounter with the situation that the university shutdown might drag out longer than we expect it to be. So we're not really sure that final examination gonna happen. In that case, maybe we need to use another assessment type, not the exam, to assess your abilities. We're gonna keep update about that topic later on. We will have big meeting in university next week, and we consider how we're gonna run this semester. So rather than those kind of situation, come back to the lecture. Like the first part, I'm talking about searching algorithms, and the most effective one is actually the one that use and work around the sorted data structure. With those ideas in mind, then we need to have good and efficiency, like quite effective sorting algorithm as well, in order to have effectiveness in the whole system, because you need to sort the data first before you search it. Okay, so go back to the sorting algorithms. What we're gonna do is that in sorting algorithm itself, the meaning is very simple. We just reorganize the element in the data structure, sorting from low to high, from high to low, or any other rules that you have in mind. But the basic thing that we're gonna use an example of the whole lecture is just from low to high numbers. Okay. Then in each scenarios, the different sorting algorithm gonna perform differently, and is gonna have benefit and disadvantages, like pro and con, to put it simple, in different scenario and different circumstance. So we want to show this animation to you, and you're gonna realize that in the different initiate state of the data, different sorting algorithms gonna work effectively or ineffectively, depends on the algorithm itself. So in this sorting algorithm section, I would like to giving only 3 sorting algorithm as an example. It's gonna be selection sort, bubble sort, and quick sort. Why we need to learn these 3 algorithms? Because I want you to learn the algorithm first, then we can consider which data structure that we should use for each algorithms. As I mentioned before at the beginning of the class, that this data structure class is not mainly aimed for learning algorithms, but you need to know a little bit about algorithms. Then you can making decision like, okay, in this algorithms, when we're gonna implement it, which data structure should we select it? Okay. Then for selection sort, how it's work is very simple. So we look at the minimum data all the times. Okay, you have random data set, like shuffle the card, for example, and then you're gonna have random number of the card on your hand from left to right. Then what you do is you're searching for the minimum value and put it on the left. And then you partition it to be, okay, the left one is the one that I already sorted. Then you found another minimum value and put on the left hand side again. So keep searching for minimum value in unsorted file, and then put it back to the sorted pile. So look at this animation. Okay, we're gonna keep searching for the minimum value. For right now, the minimum value is changed from 2 to 1, and then we swap the 1 to the first position. Then we're making the partition right there. Okay, and this partition gonna show you that, okay, here is a sorted segment and here is unsorted segment. So you keep find the minimum value in unsorted area and then put it back to the end of the sorted area. Keep doing this. So concept is very easy to understand. Okay, so basically you just imagine like how, like searching for the minimum value all the times and then put it back to the sorted area. Just that simple. Okay, so thinking about that, then can you write down pseudocode or flowchart of selection sort, because that is the most simplest one. And then from what you see in the animation, you can imagine that selection sort, it seemed to be very slow process. It's like, okay, if you have like 10 cards, it's gonna be pretty easy. But then imagine you have like number from like 1 to 10,000, for example, randomly shuffle orders. You find number 1, go back. You find number 2, going back. You find number 3, going back. So the searching times is gonna be extremely long before you be able to sort the whole data. So the next question that I would like to ask you to thinking about, and then we might discuss about it in Q&A session, is that what is the scenario that selection sort is going to be used? So what is the pro of selection sort? Why we need to learn it right now? Is that because only it's simple and easy to implement, easy to be the good starting point? Or is have any application that we should really consider using selection sort more than any other algorithms? So please thinking about that. Okay, next is gonna be another simple concept of sorting algorithms. Not that easy to, but then this one is gonna be like not that easy concept like selection sort, but then easier to implement. The idea of bubble sort is that, okay, you swap two pair of information if the left side value is lower than the right side. For example, in the random order of number, if the first pair is 5 and 3, then 5 is higher than 3, so you swap position. Okay, that's simple. And then you go to the next pair, then now it's going to be maybe like 3 and 2, 3 is still higher than 2, and then you swap. And then you keep doing this until the end of the array, and then you do it again and again and again and again until you cannot swap at all. So if you cannot making any swap, then algorithms is going to be n. Then you can imagine that there's going to be more likely to be recursive function. Like if you not forget the recursive function from the basic C class, maybe in your first year. So you look at the, like we have the window of data, and then we have the window of data, and then in each pair we swap if the left side is higher than the right hand side, and we keep doing it again and again and again. Then you can see like the higher value gonna start and go to the right hand side, and then the lower value is going to go to the left. So if you keep doing this process, then number 1 is going to be on the left hand side, and 8 is going to be on the right hand, and it's going to be sorted. So can you write down pseudocode and flowchart, or pseudocode or flowchart of bubble sort algorithms? It's going to be very simple. And then we move to the next one, which is quicksort. And quicksort is going to be harder thing. It's going to be a pretty complicated concept, and I would like to go through this quicksort algorithms with you guys step by step. So the name quicksort is coming out because it's very effective. is more likely to be faster than any other sorting algorithms in most of the scenarios, simply because it's working around the idea of divide and conquers algorithm type. So the key concept of quicksort is that you're going to have pivot, you're going to have high, and you're going to have low index value. So you have 3 index of data, and this interaction between 3 data points gonna be able to sort the whole data structure in the most efficient way, more likely or not. Okay, so look at this animation first. I'm gonna let it run briefly. Okay, so you can see how quick it is. Okay, see it again. And keep thinking about this, how it's work, how it's really work. Okay, now I would like you guys to pause the video or rewind this animation, or you look at it again in the website below. Okay, I would like you guys to thinking about the interaction between high, low, and pivot position, and try to imagine how this algorithm first working first. Okay, you can pause it right now until you can thinking about it, or you kind of like give up on thinking about this. Then if you're finishing those process, then we can come back and look at the explanation. Okay, go to the explanation of quicksort. How it works is that pivot is work as a reference point. So pivot itself, I would like to mention that pivot itself can be randomly picked, can be first position, can be middle position, or can be the last position. It really depends on the variation of quicksort that you can implement. If you look at like the complex algorithm class, you're gonna see that those quicksort have many variations used in different scenarios, and they're gonna pick pivot in the different position by the nature of the data itself. Okay, then we come back on the simple logic of the quicksort. Not really simple, but then it can be easily explained step by step. So first of all, high and low index always do comparison to each other and pivot all the times. Okay, then the first rule is that if low position is not greater than high, then increasing the low index. Okay, from this starting position, then here is gonna be P1. Okay, we select the last one, gonna be P1, the number 3 being P1. So here is gonna be low position, and here gonna be high position. So you can see that, okay, if low compared to pivot, which is 2 and 3, low is really lower than pivot. So the low index move from the first position to the second position right there. Okay, then what we're gonna do next, if low position is higher than pivot, we're gonna swap position between low and high, and then we decreasing the high index. Then we keep repeating this process again until low index is go higher position than high index, and then we swap low position and pivot position. So how it's gonna work? So we're gonna move along this process step by step together. Okay, I want to make it highlight again that 3 is pivot. Okay, and from the last process, the second index is low position. Here is still high position. Right now low is 6, high is 4. Okay, 6, the only thing that we make comparison is low making comparison to pivot. Okay, So 6 is higher than 3. In this case, so we swap low and high. So it's going to be 4 here, it's going to be 6 here. Then next, we decreasing high for one step. So right now, high point to the number 1. We repeat the process again. We compare low index with pivot, which is 4 compared to 3. 4 still higher than 3, so we swap again between low and high. So 1 is here, 4 is there. We decreasing the index of high again to the 3 position. Then we compare low index, which is now number 1, with pivot again. Low is exactly lower than pivot, so we move the index of low one step ahead. So right now, low and high pointing at the same position. Then we compare low with pivot. So low is 5, pivot is 3. So we need to swap between low and high. But since low and high is point at the same position, what happens is there's no swap happens. But we still decreasing the number of high index one step. Okay? So right now, low is point at the third position. High is point at second position. Now low index is higher than high index. So we swap the low position with pivot. So here is going to be 3. Here is going to be 5. So stopping right there, we move to the next slide. So here is a snapshot that we're talking about. We already swapped the position of pivot from the last position to somewhere in the middle, right there. Then from now, you look at this, you're gonna see that, okay, from the left side, it's gonna be always be the value that lower than pivot. Right side is gonna be value that higher than pivot. Okay? Then we repeat the process for left part and right part separately. So here is gonna be pivot of the right part. Number 1 is going to be pivot of the right part, of the left part. I'm sorry. But then since low position is higher than pivot, so low should swap with high. But then low and high, it's in the same position. It's the same scenario. So high is go one step decreasing, and then now low index is higher than high. Then you need to swap position between low and pivot, which is 1 and 2. Now it's sorted. Then we look at the right hand side. Okay, we look at the right hand side. Here's gonna be pivot, here's gonna be low, here's gonna be high. Okay, 4, which is low index, is really lower than 5, so we increasing the index of low one step ahead. So right now, low and high point at the same position. Next, we compare low with pivot. So 6 is higher than 5. Then we need to swap between low and high. But since it's point to the same position, again, swap not happens. Okay. Then we decreasing high index one step downward. So right now, low is in the right hand side of high. Then we need to swap low position with pivot. So it's going to be 5 and 6 right now. So now all data is sorted. Okay. Then you can see it's like I'm saying, it's divide and conquer. You use pivot. Firstly, you sort everything that everything is lower than pivot. It's going to be on the left hand side. And everything that higher than pivot is going to be the right hand side of the pivot. Okay. You looking back and forth, these two slides, it's gonna be better to see. It's gonna be easier to see. Okay, because I'm sorry. Okay, so you can see that from here that pivot is on the last position. Then after the first sorting step, everything that less than pivot is gonna be divided on one part, which is left hand side, and everything that higher than pivot is gonna go to the right hand side. Then you repeat the sorted process again on each position, in each partition, like the low partition and high partition. You're gonna do this process again and again and again and again until everything is sorted. But you can see how quick it is because you're gonna move everything very quickly. Okay, move everything that lower than pivot to the left and bring the pivot to the middle, and then you sort again and you sort this part again. So it's gonna be much quicker than bubble sort, and much quicker for sure in comparison to selection sort. So the thing that I would like you guys to thinking about, and it might be too difficult right now for you, is that at least quick sort need to have two functions: sort function and partition function. So how can you write down pseudocode of those two functions? Can you make it or not? And we're gonna discuss it in a live Q&A session. Okay, that's all for this week. Thank you for your attention. And please, if you have any question after look at these materials, please put your question on the Q&A post. I'm gonna pick up or the good question right there, and it's gonna fasten our live Q&A process. Okay, and thank you. I'm talking so long, and bye bye. See you around.